Hello everyone. The next topic we will be discussing is system call. So basically system call interface provides an interface for the programmers to the services provided by the operating system. System call provides an interface for the programmers to access the services provided by the operating system. Okay, and typically these system calls are written in C or C++ programming languages. In some cases, it is also written using assembly level programming languages. Okay, and how a user program can access the system calls. So basically, user program access the system call through something called as API. API stands for Application Programming Interface. That is, in different programming languages, there will be some set of APIs will be available. Through these APIs, it can access the appropriate system call. Okay. So some of the commonly available APIs are, there is a Windows API for Windows operating system. There is a POSIX API for POSIX based systems, which includes Linux and Unix. So Linux and Unix operating system uses POSIX API, and also we have Java API for JVM, for Java Virtual Machine. Okay, so the point is, system call is a high privileged task, and and system call can be accessed by the programmer through API, application programming inter application programming interface. Okay, so let us try to understand system call with an example. So let us assume a simple scenario of copying the content of one file to another file. Okay, so there is a source file, and the content of this particular file should be copied to another file. You can assume that source file is residing in some directory and the destination file is residing in some other directory. Okay, so this is a very simple activity where the content of the one file in one particular folder should be copied to another file in some other folder. But this small activity involves a list of system calls that we will discuss here. Okay, so let us understand what are the set of tasks required. So these are the set of tasks. So first is, we should know the input file name, that is from which file name you want to read the input. Okay, we want to read the contents, so that file name we should know. So for that we need two system call. What are they? First, you should use a system call to prompt on the screen to ask the user enter the file name from which you want to read the content. So that is one particular system call, and then user will be providing the input and you have to accept it, and that will be another system call. Okay, and then you have to get the output file name, to which file you want to read the content from the source and write into. So to which file you want to write, so that is called as output file name. So again, you should ask the user uh, through a prompt, like enter the name of the output file, like that. So that will be one system call, and user will be providing some name, you have to read it, and that read will be done through another system call. Okay, so just to identify the source file name and destination file name, for that we need four system call. Once that is done, Now you should open the input file. So for before opening, you should check whether the input file exists or not, and that will be done through a system call. If the input file does not exist, then you should stop the entire process because there is nothing to read. So then you have to abort. Again, abort will be done through a system call. Okay. If the input file exists, then go to the next step, that is check whether the output file exists or not. So now we are going to read from the input file and write to output file. So output file should be a new file. Output file should not exist already. Input file should exist. So if input file is not there, then you should call the abort system call. Similarly, in case of output file should be a new file. So if output file is, or if there is already a file with the same name, then it may have some content. So then, so if the output file already exists, then if we write on that again, then it will damage the contents of that file. So to avoid that, we check whether already a file with that name exists or not. If it exists, then you have to abort. So this again includes two system call. If there is a file exists, then abort. Okay. If no such output file exists, then create a new output file with that name. Okay, that will also take another system call. So if all these steps are done, then what should you do? Then you should continuously read the content of the input file and write to the output file. So that will be done through a loop. Read from input file and write to the output file. So this will loop for, it depends on the length of the input file. If input file contains 100 lines, then this loop may repeat for 100 times. If input file contains 10 lines, then this loop may repeat for 10 times. Like that, it will read and write to the output file. Okay. So how long it will read? Until read fails. So when the read will fail when the when you have reached the end of file of the input file. Okay. So all these are system call. Reading is a system call, writing is a system call. Once you have completely read from a file and written to the another file all the lines by going through this loop, then close the output file. Okay. So again, that is also a system call. Okay. After closing the output file, again use another system call to write the message in the screen stating that the operation completed successfully, the task is completed successfully, and then terminate normally by using a system call. So this is a very small activity of copying a file from one folder, from one file to another folder in another file. But it involves so many system calls. So you can understand when an operating system is running, it may be executing how many system call in a given time. So there may be plenty of system calls keep running. Okay. So this is how system call works. Now let us try to understand what is API and how it works. API stands for Application Programming Interface. So from the programming environment, the programmers will not directly access the system call. Rather, they will access the system call through some API. Okay. So let us try to understand the API for read operation. That is reading the content from a file or from a socket or anywhere. Okay. So basically this is a command which we have discussed in the lab. So if you want to know about any command, then in the Linux terminal you can write man read. Man means manual. Man means manual space the command name. So that will give the details of that particular command. So if I type man read here, I will get the manual page of that particular read command. Okay. So what it says in the sense, the name of the command is read. So where it will read from a file descriptor. File descriptor in the sense, it can be a file or it can be a socket. Okay, from any stream it can read. And this read command, it is available in the header file unistd.h. Okay, Unix standard io.h. Okay, unistd.h. And this is the syntax of that command. It returns a value of type size underscore t. Okay, and the name of the function is read, and it takes 3 parameters. Okay, what are they? The first is a file descriptor of type integer. The second is a pointer to a buffer. Third is the maximum how many bytes you want to read. So these are the information it takes. And it returns a value of type size underscore t. What is size underscore t? See, basically this is one form of integer. Size underscore t, it is one form of integer. And s represents, it is a signed integer. So basically it will return a signed integer. Okay. So it will return either a negative number or 0 or a positive number. Okay, if it returns a positive number, then that means it is returning how many bytes it read. If it returns a positive number, it represents how many bytes it read. Okay, if it returns 0, it means the file has reached the end of file. If it returns -1, it means there is something error in the read operation. Any negative value, not only -1. So if this function returns a negative value, it means that there is some error in the read operation. If it returns 0, it means that the file or the socket or whatever from where you are reading, it has reached the end of file. If it returns a positive value, it means that it has read that many bytes. Okay, so this is basically an API, application programming interface, used in Linux to read to a buffer. Okay, so 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 that is what we are seeing here. Okay, so whatever I told here, that's what explained here. So this represents the return value. Basically this is one type of integer. It is basically one type of integer. It can take either a negative value or a positive value. On successful read, it will return the number of bytes. Okay, and 0 indicates end of file, and -1 indicates there is some error has occurred. And this is the function name, and these are the parameters. ft is the file descriptor, and this is a pointer to the buffer where the data will be read. And this count is also again of type size underscore t. Okay, this is signed, this is unsigned. Okay, this here there is only one yes, which means it is unsigned. This is also one form of integer. So this represents the maximum number of bytes to be read into the buffer. Okay. So when this API is called, it will call the appropriate system call to perform the corresponding read operation. Okay. Now let us see how system call is implemented. Okay. So for every system call, a number will be associated with every system call. That is, when the user executes an API, application programming interface, then there will be a number associated with that. Through that number, the appropriate system call will be identified and it will be invoked. So there will be a table. There will be a table which maps every system call with a particular number. Okay. So when the user program, when any API is called, the operating system will identify what is the number associated with the system call, and then it will go to the table and it will check that particular number, and from that it will identify which routine to be executed. Then it will identify the appropriate system call and it will execute it, or it will invoke it. Once the appropriate system call got invoked, then the control will go to the kernel mode. Control will go to the kernel mode. Then that particular system call will execute, and after completing the execution, it will return the status of the call. It is whether it is successful or failure or what, and also it will return some values if at all, if there is any value to be returned. So the user or the programmer who is calling the particular system call through the API, he is unaware of the implementation of the system call. He don't know how the system call is implemented. He just calls to the appropriate API. Okay, and but the actual implementation may not be that simple or that straightforward. It may include some complexity, but those complexity will be hidden from the user. Though those complexity will be dealt by the operating system, the user will be unaware of the implementation of the actual system call. The user will only invoke the call, only execute the appropriate API, and then the appropriate system call will be identified through the particular number associated with the system call, and it will execute. Okay, but the actual implementation of the system call will be hidden from the user. That's the point. So here is a diagram which shows how system call works. So this is a user application. Maybe at one point of time, the user may want to perform a system call. So he will execute the appropriate API. Once he executes the appropriate API, the operating system will identify the number associated with the system call. Then it will check in the table where it maintains all the system call and all the system call number. Then it identifies which number this system call belongs to. Okay, then and then the routine corresponding to that particular system call will be executed. Okay, after executing whatever the status, that status or any return value, that alone will be returned back to the user application. Okay, but the actual implementation of this will be hidden from the user. User will not be knowing how this system call is actually being implemented. Okay. So this is how system call works. Okay, then the next thing we'll be discussing is parameter parsing for system call. So some of the system calls may need some parameters. Okay, so how to parse these parameters? So these parameters can be parsed in three different ways. There are three methods to parse the parameters for the system call. The first method is through the registers. So whatever the parameters are there, you just store it in some of the registers. Okay, this technique is sufficient if the number of parameters is limited, because the number of registers is limited. Okay, if your computer has only 10 registers, then maximum you can pass only 10 parameters. Okay, but if your computer has 10 register and you want to pass 20 parameters, then this technique cannot be used. Okay, so this is a very simplest technique where you can pass all the parameters to the registers, but this is applicable only for a limited number of parameters. The second technique is by passing parameters through block or table in memory. In this case, what you do in the sense, whatever the parameters you want to pass, you store it in memory. Say you want to pass 100 parameters. Okay, then what should you do in the sense, you store all the 100 parameters in the memory. So in memory, say from some location, say location 0 to or let us assume location 1000 to location 1000 to 1099. Okay, 0 to 99, that is location 1000 to 1099. So in each of these location you are storing one parameter. All these location contains one parameter. Say this contains parameter 1, this contains parameter 2. Like that you are storing all the 100 parameters. And then what you should do in the sense, you should specify the starting address, or you should specify the address in one particular register. So CPU has many registers. Say one register is called as A register. In this register you will specify from which location you should access. Okay, 100. Okay, 1000, some 1000 location. Maybe in another register you can specify till which location you should access. So 1000 to 1099. Okay, so it means what? So we are now using the registers only to not to store the actual parameters, but to store the starting address and the ending address of the parameters. So the parameter starting address is 1000 and the parameters ending address is 1099. So it means that the operating system will understand for this particular system call, the user is passing so many parameters and these parameters can be accessed from this location. So this is the second method of parameter passing. And the third method is by using stack. The operating system may maintain a stack and the user will push all the parameters inside the stack. Whatever the parameter he want to pass, he will push inside the stack and the operating system will pop from the stack. Okay. So the user is the one who is invoking the system call through the API. Okay. So there will be a stack maintained and user will push the parameters to the stack. So you will push like parameter 1, then parameter 2, like that you will push all the parameters. So like that you will push all the parameters, parameter 1, 2, 3, all the parameters will be pushed inside the stack and operating system will pop this particular parameters and it will use. Okay. So these are the three ways of parameter passing, either directly through registers or by storing the parameters in the memory and passing the address through the registers. The third method is by the user will push into the stack and the operating system will pop from the stack. The first method is used when there is limited number of parameters. The second method is used, the second and third methods are used when there are more number of parameters. So in case of second and third method, there is no limit on the number of parameters. You can pass any number of parameters to the system call. Okay. So here is an example for the second method, how the parameter is stored in memory and how address is passed through the register. So there is a parameter X which you want to send to the system call. So the user program, what it does, it is storing the variable X in some particular address and that address, load address. So load means that particular address is loaded into register. It's not the value of X, the address of X is loaded into the register. Okay, now the operating system, it is executing this particular system call 13. Okay, user program is calling this system call 13 through API and operating system wants to execute the system call. Now it needs the parameter. So how it will get, it will refer the register. So register contains some address. From that address, it will pick the value. Like that, it will get the particular parameter. Okay, so this is how parameters are passed by storing in the memory and sharing the address through the register. Okay, so this is, so that's it about system call. Okay, so what we have discussed in the sense, so basically system call provides an interface for the programmer to access the services provided by the operating system. And system calls are implemented in C or C++, sometimes in assembly level language. And normally these system calls are not accessible directly, they are accessible through API. And different operating system supports different API to access the. We have discussed one example for an API for the read operation. Then we have discussed how system call is implemented. So every system call will be associated with a number and operating system will maintain a table for each system call and the respective number and the routine to be executed. So when an API is invoked by a user program, operating system will identify the appropriate system call number and it will execute the routine. And then we have discussed what are the three methods of passing parameters for the system call. Fine, we'll stop here. Thank you.